Hello, welcome back. I would like to introduce this new presentation regarding the application or performing the ANOVA, single factor ANOVA, but with the using of the Excel. First of all, before starting the analysis or the one-way ANOVA analysis, we need to ensure that the analysis tool pack is already downloaded. If not, it is very easy to download it simply by these following steps. First of all, click the File tab in the main page of the Excel. After clicking the file, this new window appears. Then we click on the options in the left column. So this windows appear. This is the windows for the Excel options. We need now to click the add-ins in the left column. Then we need to click on the analysis tool pack. Then click on the go button. So this new windows appear, which is the windows for the add-ins. We make a check for the analysis tool pack, same like what we see in this windows. Then we click OK. So by these steps, the data analysis or the tool pack analysis has been already installed or downloaded. If you want to make a verification that the data analysis is already installed, simply click on the data on the home page of the Excel. Then at the extreme right, there is an icon called data analysis. So these are the steps in order to download the analysis tool pack. After you click on the data analysis, the following dialog box appears. We see here many of the analysis, statistical analysis, starting with the ANOVA single factor, which is our interested in this presentation. We have ANOVA two factors, we have correlation, covariance, F-test, etc. I would like to solve this question using the Excel. Here we have 4 groups, and for each of these 4 groups we have 5 replications or 5 observations. We need to make the one-way ANOVA analysis to test the null hypothesis for the means of the following 4 groups. So this is our question here. We have 4 groups, group A, group B, group C, group D. We want to perform the one-way ANOVA test using the Excel in order to test the null hypothesis that states that the means for the 4 groups are the same. So first of all, we need to click on the data. Then to the right here, we click the data analysis. So the data analysis windows appear, and we have many analysis tools, starting with ANOVA single factor, which is our interest. Of course, this question is related to the one-way ANOVA because we have only one factor. So we click the OK. First of all, the window asks you regarding the data input. What are the input range? Simply we cover all the records with the titles or the labels for each group. So the range for the input is from cell B4 till cell E9. Notice that there is a $sign between B4 and E9 just to make or to fix the values in order to facilitate the analysis. Then he asks you grouped by. Of course, the data are labeled in a column, so we tick the column, or the default is the column, and check for the labels in first row. First row here is the title of the groups. Then he asks you about the significant level alpha. You can change the significant value of alpha. Let it, for this example, to be 0.05. Then he asks you about the output data. If you want to keep the output data in this sheet, just click the output range and then define the starting cell to present the results of the one-way ANOVA. If you want the analysis or the result to be in a new worksheet, simply you can click at the new worksheet. If you want in a new workbook, you can click easily the new workbook. Let's keep the results in this sheet. He asks you where is the range. Let's say that we need the records or the result to start from this cell, which is the cell H5. Then click enter. So he defined the output range in H5 as shown in this window. Then click OK once again. So the final results appears same like what we have here. This is the title of the analysis. It is ANOVA single factor. These are some descriptive statistics regarding the four groups. For example, group A, count 5, the total or the sum of the observations is 19. So the average is simply dividing the sum by the count, so it's 3.8, and also the variance of the records for group A is 1.7. Same for the other groups. In the table below, the ANOVA result, the source of variation. Of course, for the one-way ANOVA, we have two sources. We have the between groups and we have within groups. Within groups is the same as the error, the SS for the error, but the Excel write it within groups. And here we have the sum of square, the SS. So between groups we have 14.15. Within groups or the error we have 25.6. So the total is 65.75. The degree of freedom is 3 because simply we have 4 groups. So 4 groups minus 1 is equal to 3. Regarding the degree of freedom for the within groups or the error, it is 16. It is simply calculated by knowing the total observations. We have 20 observations, so 20 minus number of groups, which is equal to 4, so it's equal to 16, and the total is 19. Here is the calculation of the mean square, simply by dividing the SS by the degree of freedom for the between groups, and for the error is 1.6. This is the value of the calculated F. This is the value of the probability, and this is the value of the F critical. Of course, you can make some changes or some modification. For example, we need for the SS the data to be in 3 decimals, so we return back to the home. So we click here to increase the decimal. So by this we have 3 decimals, and also for the rest we need to decrease the number of the decimals to be 3. So you can click here for the decreasing of the decimal till it becomes 3 digits. So in order to have or to draw the conclusion, simply we can compare between the calculated F and the F critical. As you see here, the value of F is greater than the value of the F critical. So the conclusion is to reject the null hypothesis, which means that we should accept the alternative one, and the alternative one states that one of the 4 means at least is not the same as the other. The other way to make the same conclusion is to check for the probability value. As you see here, the probability value is 0.001, which is simply less than the significant level, which is 0.05. So we can simply conclude that we reject the null hypothesis and accept the alternative one. So this is the way how to make the analysis of variance for a single factor by the Excel. Let's try to change the significant level to be 0.02 instead of 0.05. But first take care to the value for the F and the F critical in case of 0.05 significant level. So let's delete these data and start the analysis once again. So click data analysis, ANOVA single factor, OK. He already defined the range for the input from B4 till E9. It's grouped by columns, labels in first row, which is the title of the records. It is the group A till group D. But now we need to change the value of alpha to be 0.02, and we need to present the results in this sheet. So you should determine the starting cell. So let's say, for example, we need to be in this cell, which is the cell H8. So click OK. So he defined a new output range, which is H8. Notice that the $sign in order to fix the values using the analysis here, and click OK once again. So we have this new data. Of course, there will be no change for the summary. but we have some new records for the ANOVA table regarding the value of F and the value of P and the F critical. Once again, the value of F is greater than the value of the F critical. So the conclusion is to reject the null hypothesis and accept the alternative one. And another criteria to make this conclusion is to check for the probability value. Again, the probability value is less than the new significant level, which is 0.02. So we should reject the null hypothesis. That's all about the performing of the one-way ANOVA or the ANOVA for single factor using the Excel. Thank you and goodbye.